first meetup of the San Francisco Infrastructure as Code. My name is Chris McGue, and that's Zane over there. He's the co-founder of the group. And we kind of wanted to go over what we're going to talk about today. People who've helped, ideas behind the meetup, Zane's presentation, and the conclusion. So I'd like to thank the team here at Zillow Group. Elise Snyder is the wonderful woman who set up everything so that we have a nice pizza and a place to sit. Chris Sessions from the infrastructure team here at Zillow, who is probably one of the best infrastructure managers I've ever worked for. He's a great guy. As well as the IT team here at Zillow who helped set everything up. And Pam, who was down in the lobby guiding people, thank you. Oh, great, this doesn't show up. That's nice. Okay, well, we have a bunch of open positions here at Zillow. Some data engineering, some product management. These slides will be online later, and hopefully the links will be visible. And they are all full-time here on premise in San Francisco. So why do we need another meetup? This is kind of a question. My wife's like, you go to a lot of these things. A lot of the meetups that we've had here in San Francisco are pretty product specific. And that's great, but I kind of want a better sense of what people are doing, not tied to any specific technology. And I know everybody's drowning in free time, so we'll try and keep it as informative as possible. So technology agnostic, puppet, chef guys, put them in a room, knives come out, until the Ansible people come in and everybody makes fun of them. But I'd like it to be as technology agnostic as possible. Focus in using infrastructure to increase velocity. We want to help people get code out quicker. We want to drive the bus, not get run over by it. And provide real-world production details. I think this is pretty critical to what we're talking about. So one of the things that when I'm giving a presentation at a company about a new technology, we always talk about, I always have the no silver bullet slide. Right? If we can just go to Docker, everything will work great, and we won't have any problems ever. Or if we can just go to the cloud, we'll never have a problem ever. And we all know as technologists that is not true. So I gave a presentation for a CTO of a large company, and I included the silver bullet slide, and he said, oh, you are telling me that this technology is not perfect and how we get around it? And he's like, yes, I want to work with you guys. So it's being honest and going through some of the drawbacks in your technology is a very powerful thing in dealing with people. Any bugs? One of the interview questions that I like to ask is, tell me about a bug in a software that you use that you found. That tells me that you really know the software and that you really know what a bug looks like. So when you deal with developers, it's easy for you to show them how to reproduce it. And at the end, probably reflect on any possible improvements, right? So I did the first generation of Terraform here. Zane did the second. I made a lot of mistakes. I did it really fast under pressure. And Zane came in, looked at it, pulled it apart, and put it back together. So he did a much better job. So my reflection would be that Zane should have done it in the first place. All right, oops, that's the conclusion. But we're looking for future talks. So if you have an idea for a talk, if you've never given a speech before, this is a great way to kind of get your name out, get used to speaking in public. Always looks good on a resume. I know there's a few recruiters here, but this is a skill that people look for. So I'm going to hand over to Zane and Marius now to do the presentation.
Check, check. Okay, there we go. Let me get set up here. Okay, great. So the title of this talk is Terraform Modules and Continuous Deployment. I am Zane Williamson, a senior DevOps engineer at Trulia on the data engineering team. Been here for about a year, been in the industry doing this type of work for maybe about 10 years or so. My associate here.
Hey, my name is Marius. So I work here as AWS consultant at Trulia. And I've been working here since February, and I work with Zane. We work with a bunch of interesting AWS projects. So the way how this is going to work, Zane is going to introduce a little bit the.
Yeah, I'll do an overview.
Then I'll come back and explain some of the decisions which we did, and then we're finally going to kick with a really cool demo.
Yep, we'll do a demo at the end. We'll cross the fingers on that. So for an overview, we'll be discussing. I'll discuss here the challenge that we faced, the system overview in a nutshell, why we chose Terraform and Packer for the continuous deployment process. Marius is going to dive into the Terraform modules and how we're using them, and a little bit more deep dive on that. Then at the end, I'll do a quick demo of a continuous deployment using Jenkins, Terraform, and Packer. So the challenge. We needed to deploy an array of microservices across multiple teams, multiple AWS accounts. Each of these microservices were in various states of development, and the cloud configuration, the infrastructure configuration needed to be repeatable. We needed to have it to be peer-reviewed by the different team members engineering these microservices. We wanted tooling that was flexible, yet easy to use, so that non-experts in infrastructure as a code type of field could grab it and roll with it easily. So for a system overview, this is sort of a kind of a high-level snapshot of maybe one of the AWS accounts on the data engineering org, and kind of like what the infrastructure layout looks like. We're using AWS as our primary cloud provider. We have multiple microservices, APIs, some with ELB endpoints, some without ELB endpoints, acting more like worker instances. And then each of these environments will have a common shared backend in a core-like environment. So, for instance, Kafka, SQS, S3, HBase, RDS. So we started out using Terraform initially in Packer and a little bit of masterless Puppet to manage some of the core infrastructure, like your VPC, the subnets routes, the shared backend services. Terraform took care of quite nicely for us. But then we get to the portion where our microservices are kind of like coming into, okay, we need a dev environment, stage, and prod to start testing this out. So we needed to pick a tool or set of tools that would work well for us. So those ASGs there would be the example of the microservices that need to be deployed out. They would live in auto-scaling groups with ELB endpoints. So what were we going to use? And we basically boiled it down to using Packer and Terraform. And I'll discuss a little bit about Packer and why we chose to go with Packer. First off, the devs, the engineers, the ops personnel, we're already pretty familiar with Packer, using it for some of that core infrastructure, and then using it for a lot of stuff that Chris is working on the ops side for the Elk setup there and a bunch of other things. So there was already some familiarity with it. It allowed us to reuse Puppet modules so that if we develop a module in a Puppet masterless-like environment to create like a Kafka node, let's say, that same Puppet module could be easily used within our data center. So there was some mobility there that we liked, and it integrated really well with Packer. So we liked that. Multiple outputs for Packer, VirtualBox, Docker, AMI. We really liked the flexibility of having those multiple outputs. We decided, obviously, we'd be using the AMI most definitely for releasing the code into the auto-scaling groups. We'll talk a little bit about that in a bit here, and that'll be part of the demo. Number 4 is super important, I think. Packer was flexible enough to be able to embed easily into the source code of the microservice, like have a deployment folder, transfer essentially ownership of and knowledge of this tool into the microservice, giving the developers a little bit more power to control what they're building on AWS. So that was something we liked about it. Easy to integrate and call from Jenkins. That was important because we use Jenkins for our CI system here. why we chose Terraform. So we have Packer to build the AMIs, and then we're going to have Terraform to manage the infrastructure. We looked at CloudFormation. It was, at the time, a bit limited. It didn't have a plan feature, which was kind of lame compared to Terraform, but they added that a little bit later. It would box us into AWS, and that was not a good thing necessarily, where Terraform gave us some flexibility to spread out to other cloud providers and other providers outside of the cloud. Libraries like Bado, Fog, where object-level programming skills were required, and they didn't manage state very well, so we kind of said, oh, those have their fit, but not here necessarily. Some developers, ops people like Packer were familiar with Terraform. This also pretty easy to integrate into Jenkins. Marius will talk a little bit more about how we use TF-ENV, an open source project, to manage multiple versions of Terraform, which was nice on a single Jenkins instance, and then each of your jobs would be able to leverage a newer version of Terraform. We'll talk more about that later. Ability to put Terraform directly into the code base, just like I was mentioning with Packer, super important for each microservice. It gave the engineers the power to leverage the cloud as they needed for their service and design their application to run on the cloud, and got to put that right in the code base, and we'll show a little bit in that demo. And then lastly, leveraging Terraform modules was pretty important to us to kind of help with the organization of the Terraform and for sharing Terraform modules between our teams, and that was pretty important. We use Stash and Git, so it was a great place to localize modules for sharing. And with that, I'll pass it over to Marius, and he's going to describe some of the challenges we face in regards to modules.
All right, thank you so much.
You good?
Thank you.
Cool.
All righty. Thanks, Zane. So basically, what we have here is, what I want to start is with some of the challenges which we're facing. Like Zane mentioned, we love Terraform. Like a lot of people using it, experience. And maybe this is like reflective of like what Chris was mentioning, like the initial version. So we have some challenges here because we have multiple teams which are working as individual units, and they're each working with Terraform. So this inevitably caused either some code duplication or some code drift. So basically, either team ended up copying the same code from the other ones, and then like we would end up with different versions of the same code. This also caused management and maintenance issues. So basically, if we would want to make a fix, if we would want to make a change, we would basically have to go back in all those places. Also caused a bunch of problems with testing. It was not easy to test the impact of a change. You would have like a much bigger scale to run your test. And we were bit by different versions of Terraform. So before moving forward, I just want to see how many of you are using Terraform right now. Okay, so maybe this was not a good question. How many of you have never used Terraform before? All right, so we have some people who have not used Terraform before. So this is like a little bit of more of an advanced talk, but I'm hoping that you guys are going to get something out of it, at least how powerful it is and some of the lessons which we learned, so you don't do the same mistakes. Alrighty, so like one of the criterias which we liked Terraform was modules, but in the beginning we're not really using modules. So we asked ourselves, like, are Terraform modules like the solution to all those problems which I mentioned? And you probably guessed that it is true. But because also we have some people who have not used Terraform, I just want to go over and explain a little bit the basics of what Terraform modules are. So basically, modules are very, very simple. So they are just a way for us to create reusable components. And they can be anything. Like any resources in Terraform can be wrapped into a module. These are just like some files put into a folder, and it's that simple. So I'm going to show you some example so to get a better understanding. So this is just an example module, an ELB, which Zane is going to run afterwards in the demo. And you can see here we have some documentation files there, a changelog, a README, and then we have some Terraform files. We have also a test folder where we have a test file, and we'll just go over and explain a little bit what each of them do. So basically, this is just like a way for us to standardize how a module looks. It's not important, so the files can be named whatever. It doesn't have to be named variable, it doesn't have to be named outputs. They can be named whatever you want. So in the variables files, we have the inputs of the module. So the way how a module talks to the outside is through variables. So here we set all the inputs which we put for the module, and we like to set like good defaults. And on this slide, I don't really have a lot of defaults, just one. But trust me, in our modules, we set very good defaults on most of them, so we don't really have to use the variables unless we need to change the default. So the main file basically contains the resources, the Terraform resources. In this example, it's like an ELB, and it's just the same thing as a normal Terraform code. There's absolutely no difference. The only thing which you can notice here is that we use the variables which we put there, like the var subnet, the security groups. These are things which we define as variables. And finally, also very important if you're using modules is the output. So in the output is the way how we communicate to the external Terraform code of our module, like what did we do, like what are the resources which we created, what are some of the important pieces which they might use in their own code. So that's pretty much it. So you use a module just like any Terraform resource with the keyword module, and the only required attribute is actually the one called source, where you tell it where to read the source of the module. All the other ones are the parameters, the variables which we have defined. These are optional. You can overwrite them or not. The source of the module can be a local folder, like it is here. It's basically the same folder as the current project, or it can be a Git repository. So it can reference an external third party, like GitHub or Stash or whatever source, and it will download the module from there, which is like a much better way to control the versions of the module. We can also use multiple versions of multiple instances of the same module. So in this case, we might have two ELBs where we pass different parameters, or we can have more, whatever the needs are. So once we have created our project, the final thing which we need to do is to do Terraform get to download the modules. If these were local, it will just create a symlink to them in a hidden folder called .terraform. If these were remote, like in a GitHub, it will download them, and also it will put them in the same hidden .terraform folder. So interesting to note is if the repository is remote, any other Terraform get calls will not update if the module exists. If you really want to get a new version from remote, you will have to use the -update parameter. This doesn't apply for the local folder. The local folder, once you've done the get, it will always create a link, and you'll always use the latest version from there. So as you can see already, here we are like pulling different versions of these modules referenced by some tags. This will be very important. So basically that's in a nutshell what a Terraform module is. It's very simple. It encapsulates Terraform resources, allows us to define inputs and outputs, and it basically allows us to reuse this code. So let's see if this solves the challenges which we started with. And the code duplication, it solves it. So now we packed everything in a module, so we have just in a single place. There's no code drift. The management and the maintenance, it's much easier because we have it isolated in a module. The versioning, like you saw with the Git, we can define versions with tags and then like lock those and use those maybe in different environments, different versions. And the testing, even if it's not directly, it helps us sort of like isolate and limit the scope of what we're needing to test. So it makes it easier to test this by itself with the module. So next I want to go over some lessons that we learned during this journey of Terraform modules. I didn't want to call them best practices because it's just like we're learning and discovering, and just like Chris said, maybe what was good like 8 months ago, maybe now it's doesn't look so good anymore. But these are things which we learn and we've seen and we like think it would be good to do. So when you use modules, try to use variables for everything and have same defaults. This will allow to customize things as you go. Maybe you don't think you will need to customize them in the beginning and you might want to hardcode stuff. But if you use variables, it's going to be much easier to customize them. We use same defaults, so it is possible to have modules which have just a name and that's it. All the things will be default. We use documentation for our modules. This is very important, especially if you work in a team with different people. We develop modules which are used by some team which we have no idea. So it is very important for us to document the modules and explain what all the inputs are, what the outputs are. Also have a change log and describe there like what changed in a new version. Maybe it has a requirement of some Terraform version. I already said this, like use Git repositories. So our initial implementation of this used a shared Git repository for the Terraform modules. This was called TF modules. And this looked cool. We separated things. We had everything in a repository. It's easy to maintain. But we realized that we cannot have separate versions. So even though it's a little bit more awkward to like have one Git repository per module, this is what it makes life much easier for testing or for versioning. Finally, test your modules. So we have a workflow which tests all our modules. So the simplest thing which you can do to test a module, you can run Terraform validate, which will basically just go over your syntax and validate if it's a valid syntax. On merges, on new versions, we run like a test build where we literally have a test, which you saw there, which builds a test infrastructure in a test account to validate that it still does what it's supposed to do. Different versions of Terraform can behave differently. So been doing this for a while. We've seen many versions of Terraform. So like just in the last month, there have been like probably like 4 or 5 releases. Like in the last, few weeks, there have been 1 release every week. So most of them are okay, but be careful that some of them might return different results for the same code. And I'm going to talk a little bit about more at the end. So next, this is not really modules related, but it's like how you would lay out your code. So basically, this is just an idea. It's pretty similar to what we use in production. We have a repository where we separate all the things Terraform in their own folder. Why would you want to do this? Basically, to minimize the footprint of your Terraform code. So as you know, some of you raise your hands, you've been using Terraform. I'm pretty sure most of you have seen bad things happen with Terraform. So we don't want that, okay? So, or if it happens, we want this to be limited to a smaller piece of the infrastructure. So that's why we have, let's say, a global folder where we would have like global resources. These might be users, these might be CloudTrail definitions, S3 buckets, whatever. And then we have different environments. And in each environment, we might have different core services, which might be VPCs, security groups, and so on. And then we have different for each microservice. And this is not entirely true. Like what Zane will show, like most of the microservices will have the Terraform code with them inside their own repository. But if that's not the case, then we would lay it up like this, so the services which don't have a code. So basically, this allows each of these folders to have its own Terraform run and its own Terraform state and isolate there. So when you separate things in Terraform, like then you end up with this problem where you cannot reference like other things. Let's say in my microservice definition, I cannot really reference the VPC, so we don't really want to hardcode that. So it's a great way to use something which is called the Terraform remote state, where basically you would read the state of another Terraform run and use resources which were created by that in our own resources. This can be done with any remote backend. It's like Atlas, S3 are examples. We use S3. Atlas is another option. And basically, like, we would do that for all our projects. All our projects will write to this S3 bucket. This is a bucket where you would want to make it encrypted. You would want to have versioning enabled if something goes bad with your Terraform state. But this also allows us to read from other projects to read this the state file and use things. Like, for example, here we use the VPC subnet ID. We could use like other parts from the core infrastructure, so we don't have to hardcode them and dynamically discover them. All right, so Terraform, just like we said, adds new features all the time. So the problem with this is when new features are added, this is cool if you're running that version. If you're not running that version, that this might cause problems. So basically, just to give you like a better example, let's say we have a Elasticsearch resource, and this Elasticsearch version is just a way to define the version. This was introduced in Terraform 0.7.1 because Amazon didn't have versions before, it was just one version. So in 0.7.1, they added this. So we add this to our module. So what happens if you run this code with like an older version, let's say 0.7.0 or 0.6.19, whatever? The Terraform will fail. So this is a problem, especially like if you don't have control of what versions of Terraform people are running. This can cause problems. So be aware when you add new features and new parameters, especially attributes, these are just going to be a hard fail for older versions. So in order to sort of like work around this problem, we found this project which is called TFEnv, which basically it's like sort of like RVM. It allows us to run multiple versions of Terraform. It's pretty straightforward. You install it, and once you have it in your path, it sort of like takes over your Terraform installation, and then you can manage it with it. So in this case, like I'm installing the latest version, and this basically just goes over and installs it. Like if like most of you are like me, you just go download from the HashiCorp the site, the D package, install, click on it, whatever. So this is just going to do it automatically. So this is nice only from that point of view that I don't have to do all that installation. But it also has like much better features. Like you can have multiple versions installed. So in this case, you can see on my laptop, I have like a bunch of versions. I cleaned up recently, but still I have a bunch. And I can use any of those. So basically I can say just TFEnv use 0.6.16 if I want to test something with that. It's that simple. So immediately the next run will use that. And what's even cooler is it has support for the file called .terraform version, which you can drop in your project and specify a version, just similar to RVM. And it's basically just going to know automatically, and it's going to automatically use that version for that project. So this is pretty cool. And just like Zane hinted in the beginning, we use this in Jenkins where we have multiple projects running multiple versions of Terraform. So this allows the same Jenkins box to switch from a different versions of Terraform as needed. So of course, we always want to run the latest and the greatest, but that's not always possible. So if you have like these kind of things where you handle and you manage multiple versions, I highly recommend this. This is a great tool. Really cool. So what I want to close, it's sort of like before handing it to Zane for the demo, sort of like this is all cool, but as the people who have been using modules knows, there are still many things lacking with Terraform modules. These are not necessarily modules related, are more like Terraform related. So for example, the missing of conditionals, it's a big problem because that doesn't really allow us to really write real reusable modules. We use all sort of hacks with counts and like all sort of regex, and we've done pretty cool stuff. But still, those are at the resource level. So if you need to do any conditional at an attribute level, let's say that Elasticsearch parameter, there's no way for me to make that optional there and say if version blah, or to make a conditional there. I could make the whole resource optional, the whole Elasticsearch resource optional, but not the attribute. So if we would have a conditional, like in any form, even very simple, this will allow to build much better modules. Like if you look out in the open source, like there are some modules which are open source, but there are not so many, and this is the main reason for that. Because if we would have like a better way to define really reusable modules, then you would see more open source modules. Terraform state locking, there's no such thing. So if you run Terraform and another colleague will run it, who knows what might happen. We run mostly from Jenkins, but sometimes in development we might run it from our machines. So this is a potential thing which you might want to be aware of. There's a project which is called TerraGrunt, which sort of like use DynamoDB and uses a locking to sort of like alleviate this. Also Atlas, which is the commercial solution from HashiCorp, I think has some way to lock the state if you are using Atlas as the remote state. So we're pretty happy with the TFN workflow, but it would still be great if Terraform natively would know that some specific file has a requirement of some specific version. Maybe even if it would not fail if you define something. That would be nice. Testing, like I mentioned, we do quite a lot of tests, but this is very primitive, so it would be great if there would be more efforts in the open source or even in core to sort of support a way to mocking or to just do a dry run on some of these resources. So like after like Zane will do the demo, we'll take questions for whatever you guys have. So just to keep the flow going. So here you go.
Cool. Thanks, Marius. You hang on that going? Okay. Cool. So I'm going to do a quick demo, live demo. And this is sort of an overview, a visualization of what it's going to be. One thing that's missing here is there's an ELB that's going to be sitting in front of this auto-scaling group. And step one, we got the live code out there. There's an ELB endpoint, and it's pointing to the current auto-scaling group, and the app is responding. Cool. So what I'm going to do is I'm going to go into Jenkins here and run a build job, compile this new code. It's just a simple Go application that does a little web server for us and presents some EC2 metadata on the web page. So I'm going to make a change. We'll build it in Jenkins. Packer IO is going to ship the AMI and save it on AWS, and then we'll promote the build using Jenkins promotion tool, and Terraform is going to then do a create before destroy, where it's going to notice that we have a new AMI version. It's going to roll out the new code in a new auto-scaling group alongside the existing code, and then it's going to delete the previous auto-scaling group for us. We'll end up with the new auto-scaling group and the new code base. So that's it in a nutshell. So before we go to the challenges, here is the ELB endpoint. And if I refresh this enough, we'll see there's two instances behind there. Got the AMI ID. And then we'll go over here to Jenkins. Got a Jenkins job that's going to help us deploy this. So we got a version running now, as I mentioned. We'll make a change to the code real quick. We'll just update the index HTML template. Give me 1 second there. We'll go into, so our microservice here, we got a source directory. I hope you can see that okay. Right here, source. And we'll go in there. We'll talk about the deployment directory here in a second. So I will update this background for this example. Let's change this to green. Updating background. So this fits in, you know, I'm going to just push this to master, but it can fit into your whatever release process you have, and then Jenkins can build whatever branch you need. For this example, to keep it simple, we'll build the master branch. So great, we've committed the simple change to the app. We'll go over here to Jenkins now, and I'm going to start the build, and this takes a second to run. So while this is running, we'll kind of peruse the deployment folder in the microservice. So Jenkins started, it reaches out to GitHub to grab the application source, which also includes the deployment directory. And it's going to first build your code, right? So if this is a jar, or if this is whatever, it's going to run through your build. It's going to hit any tests that you need to do. In here, we have a couple tests that'll run, just a couple simple ones. And then the next step will be to save this AMI, essentially run the Packer, provision a few files, run whatever other provisioner steps you need in Packer, Puppet master list. But in this example, we kept it a little bit simpler and just did a shell provisions steps, and I'll show you that right now. So as that's waiting for the AMI or the EC2 instance to come up, how many have not used Packer before? Cool. So I won't get into too much detail, but it's we'll do a quick little review of it as this is waiting. So it can be kind of slow to spin up in some cases, but it's spinning up for us right now. It's going to access SSH. We'll go into the deployment folder of the microservice. We'll enter the Packer directory, kind of split it out into the Packer step and the Terraform step. So in the Packer step, so Packer's obviously got like a pretty straightforward JSON-like configuration. Can you make the font bigger, please? Yeah, totally. So we got our source AMI, which in this case I'm using like one of the Ubuntu cloud images. Is this going to run a couple provisioner steps for us? Here's where, like, if you had a more complicated application, you would build it with like a Debian, your build step that's going on in the background where you compile your binary. Maybe you want to include like, log configuration files, upstarts, a bunch of other things, perhaps. So you could package it, make this a little bit simpler if there's a lot of things going on. But for this application, it was just one binary, one systemd file, and an index template file. But you could package a deb in your build job and have Packer ship that up to the EC2 instance, and you run a few shell provisioner commands to install it and get it rocking. In this case, I'm just going to ship the binary and the index file and run a few shell commands to get the binary in place, make it executable, make sure it starts by systemd when the EC2 instance gets called out by the auto-scaling group. I need to make sure it starts. So pretty straightforward there. And then we're obviously saving the AMI here. You kind of flag the name, add a timestamp to it. Cool. Let's see. So I'm going to show you guys a little bit while that's saving in the background. It's waiting for the AMI instance to become ready. So essentially, it's done its build of the application Go. It ran its test, and it's saved the AMI at this point. Or Packer is running, connects to the EC2 instance, the temp one. It shares the files, the provisioner that we configured to that EC2 instance. Now it's shutting it down and saving it. Great, and that's done. So the next step, once we have a new AMI, that hasn't affected anything with the live running application. Still the same AMI ID, obviously, so you can run this build as much as you want. It's the next step that becomes more of a, you're going to engage the infrastructure at this point. So I'm going to go to the build 46 that we just ran. I'll run the promotion step here, and we just called it Terraform. You can modify the command here, but it's defaulting to apply, so it's going to be a Terraform apply. Boom, kick that off. We'll watch that. And what it's going to do in this continuous deployment style, it's not going to touch the existing auto-scaling group and launch config. It's going to then instead do a create before destroy, where it's going to create the launch config. Right here, Terraform's doing this. It's going to create the new auto-scaling group. So hopefully I'm not logged out of here, but we can kind of see some of this happening in real time, I guess. Instances. So we still have our 2 existing instances up. What we're going to see here is 2 more instances will pop in here, and we'll have 4 total. So you have your old code running alongside the new code. Refresh this. So here's the previous auto-scaling group. The new one is coming online now, and it's bringing up the 2 new instances. This isn't going to see the new, it will see them, but it's going to have to pass its health checks. And this is an important thing I think I talked about in the next slide, where you want to have solid health checks for your microservice. It needs to be designed to run in AWS so that, for instance, when you're adding new EC2 instances into the auto-scaling group or behind the load balancer, the health checks need to be legit to notify the load balancer, yes, I am truly healthy. Still out of service. So give it a second to bring these guys online. Yeah. Yeah. We're shipping a new binary in the AMI via Packer to the AMI and saving it, right, for the new release.
But you're building that image in Amazon. But if Packer is a imaging tool,
Sure.
you build it locally and then.
Well, we can. I'll get back to that in the Q&A. Let me wrap this up because it did finish here. But that's a good question. If you don't mind, we'll get back to that guy or that question. So cool. We're live. So I kind of skipped over some stuff here. We missed out on a little bit here, but let me just take a look at it. What happened was we saw that it was coming online. The 2 previous instances are now gone. If I would have been refreshing the page a little bit more repeatedly, we would have saw that the background of the old code and the new code would have been in play at the same time. But now, as you can see, the change is completely live, and the previous auto-scaling group should be in a destroy mode right now. And that's what this icon represents here, is essentially this guy's being removed. And we go back here to Terraform, we'll see, yep, it initiated the destroying process after a successful creation of the new auto-scaling group and launch config. So awesome. We're back at that. We're live here. I'll just quickly show real quick the Terraform. I showed you a little bit of the Packer. So the Terraform, we call out a module that's based in GitHub, and it kind of encapsulates maybe quite a bit more in terms of Terraform lines of code into a module here that helps us with the launch config and the auto-scaling group. And then in the ELB, something similar, where we call out to GitHub to get a module that helps us build the ELB and do what we just did here with this release. So that's it in a nutshell. So it's succeeded. We're live with the change of the code, different AMI version, and that's it in a nutshell. So let me just go over the challenges real quick, and then we'll get to the questions, and I can help answer that one. Okay, so challenges and the no silver bullet. This type of release process doesn't exactly work well if you have a code base or a code that needs to be aware of its state, and you can't have two versions of your code running live. Obviously, as we sort of saw there, two were live at once. The previous code deploy gets taken away. That may not work in this type of code deployment style. So like a blue-green type deployment where you have two auto-scaling groups, one live, with 10 instances, one was 0, you spin up 10 in the other one, redirect your load balancer, bring it down, bring the old one down. Something like that may work for you. So cleaning up the AMIs, when you're doing multiple releases to the microservice, you'll have a lot of snapshots being stored in S3, so you kind of have to handle that outside of the release process here. And there's a pretty cool tool on, there's a pip package called AWS Cleaner, which is pretty solid, and we've added that into the Jenkins workflow to help trim back the number of AMIs we're saving. Your application has to definitely be engineered to run in the cloud. You can't take a monolithic application from your data center and try to force it into this style deployment. It needs to be kind of designed from the ground up to be able to work inside of an auto-scaling group, to be able to come and go whenever. Like each two instances will be destroyed without, obviously, you doing it. So it needs to be designed to kind of work with this. The auto-scaling group failure scenario, I didn't really have time to demo that, but let's say you release a new code and it brings up that new auto-scaling group, but it's failing its health checks. What Terraform will do is not allow it to go on to the next step where it destroys your previous auto-scaling group, your live one, but it'll essentially time out and fail, and then Terraform will even say at the end, hey, I failed. It's not gonna I'm not gonna clean up for you, is what it says. So you kind of have to, oh crap, I had a code deploy fail for whatever reason. I'm still live with my code. That's safe, but you got to kind of go in. There's a process outside of that release mechanism to clean up, basically. So that's another challenge that you would have to deal with in those scenarios. But besides that, pretty solid. And that's it for challenges. Now, questions. I can go back to your initial question. Can you kind of rephrase it for me?
Yeah, so Packer, if I understand it correctly,
Yeah.
allows you to package an image that's portable between different hypervisors or cloud solutions, right? So an AMI image should be being built as it is a VM image, VMware image. So you did the build, the test build on Amazon,
Yeah, so you can set outputs at the end of your Packer config, and you can change it and have multiple ones for virtual boxes, Docker containers, AMIs. So I'm calling out in the Packer config to save my EC2 instance, the state of it, once I've moved files there, and save it, shut it down, save it. And so it offloads a lot of the manual work of spinning up a temp instance, managing the security groups,